In today's You Ask, I Answer, Anika asks, data analytics is such an awkward phrase. What is data analytics and how is it different than data science? Great question. There's a lot of confusion about all these different terms, particularly since a lot of vendors in our space like to mix and match these terms together, and they're not necessarily easy substitutes. So let's dig into this. Data analytics is exactly what it sounds like. It is the analytics we run on data. And so this can be any kind of data at all. We can run it on customer data, on machine data, on IoT data, healthcare data, search data, census data, manufacturing data, so on and so forth. Whatever the data is, we run analytics on it. We apply analytics to it to understand what happened. That's the key of analytics. Whenever we say the word analytics, we are using, we imply to mean that we're going to unlock, to loosen up, to free. Analytics comes from the Greek word analyne, which means to loosen up, to unlock. So data analytics is the process of unlocking data. Now, there are also other functions, other things we do with data. There are the insights we gather from data, the intelligence, the insights, sort of why is stuff happening. And then there's the management of the data itself, which is, think about IT and engineering and servers, big data, all that stuff. If we overlay, and in fact, let's put up a fun diagram here. If we overlay data analytics as sort of the what, the business intelligence where we have the management of our data and the people who need our data as sort of the why, and then the management of our data and the technologies and tools themselves, that's sort of an engineering function. When you put all those together, intelligence, analytics, and engineering, you end up with data science, which is sort of the blanket umbrella term of the science of data, the science of making data useful, of getting good stuff out of our data. That would be my interpretation of how these different disciplines interact. When we think about the management of data, purely that is very much an IT function. We think about the data technologies, that's very much sort of a software function. So IT and software, different things. Management of technology versus the coding and the creation of technology. That coding and technology, there's a lot of, that's where your machine learning and AI sit. And then the people function is the business function, domain expertise. It doesn't necessarily have to be human beings, but it is that sort of the business, the why of the stuff. You think about people, process, and technology. People is why are we even doing the thing? Well, there's people who need the thing. What is the thing? Which is platforms, and then how do we manage the thing? And that's process, right? Process is very much all about how. And so when you intersect these things together, that intersection of the why and the what, the people and the platform, is your data analytics. Like, why are we doing this thing? Well, what are we going to do with the thing? Let's get some analytics on that. Let's understand what happened. When you look at the intersection of people and process, the why and the how, that's where you get the intelligence, because you need those insights to inform the what. So we know from analytics what happened. Now we use intelligence and insights to figure out why those things happened. And then how do we automate and scale and build for growth? That's an engineering function. That's the intersection of the what and the how. We want to boost up our ability to grow, to scale, to automate, to standardize, and to accelerate our business. That's one of the reasons why machine learning and AI very much fit in that intersection between platform and process and engineering, because it's very much an engineering function to help us grow faster. Some of the things you'll hear, like exploratory data analysis or confirmatory data analysis, that all fits in data analytics, and that is very much people trying to figure out what's in their data. When you put it all together, why, what, and how, that becomes data science, and that becomes the overlap that you can specialize in, but you can see how being a data scientist would require you to have experience in understanding the intelligence of the business, the analytics of the business, and even some of the engineering of the business. That's also why data scientists are in such short supply, because you have not one area of expertise, but you have 3 domains of expertise that you need to be fluent in. You may specialize in analytics, or you may specialize in engineering, you may specialize in AI, or you may specialize in visualization, but you need to have competence in all three in order to fully bring that data science alive. So one of the reasons why data science is so expensive, so hard to build as a capability, is because you need people who can do all three things. So very good question, Anika. Very challenging question. And I will caveat all this by saying that if you were to ask 100 data scientists and analysts and business intelligence professionals and engineers this same question, you're going to get very, very different answers. So understand that this is my perspective as someone who is okay at all three of these domains, and that it is just one person's perspective, but this is how I would organize my thinking around this, and this is how I'd organize teams of people around it, or how to choose vendors. If you have a vendor that's saying, oh, we do all this, well, really? I mean, how many data scientists do you employ who can bring to life the engineering, the analytics, and the intelligence aspects? If the answer is 0, then you are not a data science tool. You are not a data science software company. What we've seen happen a lot in the space is vendors who've specialized in one of those areas, like BI or analytics or engineering, trying to pivot and hop on the data science train because they can get bigger budgets, or it's more attractive to buyers, but lacking the underpinnings to actually be a data science tool, as opposed to being an analytics tool or an intelligence tool or an engineering tool. It's okay to be in just one of those things. If you're really good at it, you want to be best in class in that thing. If you're a best in class analytics tool, awesome, be that and people will buy it. But if you as a business user are trying to figure out, okay, we have all these software packages, try classifying them into the analytics, intelligence, and engineering categories, just on the back of a napkin or whatever, and that might indicate where you have technological gaps. It might indicate where you have process gaps, and it might indicate where you have knowledge and skills gaps on your staff and the agencies you work with and things like that. So use this framework to help categorize your relative strengths and weaknesses in data science, in data analytics, in business intelligence, and in data engineering. This framework should help you have a little more clarity about what you've actually got under the hood. Again, great question, Anika. Thanks for asking it. As always, please subscribe to the newsletter and to the YouTube channel, which is where all the historical videos for all this stuff is kept. So if you want to go back and look at old episodes, it's easiest to find them on YouTube. I know a lot of folks watch us on LinkedIn. Thank you. But the historical stuff's all on YouTube. Easier to find there. And we'll talk to you next time. Thanks for watching. If you want help with your company's data and analytics, visit braintrustinsights.com today and let us know how we can help you.